This is a specifically designed video for the students who are going to give AIPMT exam. AIPMT examination for medical entrance to MBBS courses and BDS courses. Various times we will study more which is not required. So what is being asked in AIPMT should be judged from what has been asked in the previous years. So I am giving you some basics for the previous year's questions, recent 3-4 years, so that you can take the main idea what is being asked and which type of questions are being framed by the AIPMT people. One by one we'll go for it. This is for the electrostatics chapter only, so we'll talk of those chapters. 2015 AIPMT question था, a parallel plate capacitor of capacitance C is connected to a cell of EMF V and then disconnected from it. A dielectric slab of dielectric constant K which can just fill the ear gap of the capacitor is now inserted in it. Which of the following is incorrect? We have given 4 options. The potential difference between the plate decreases K times. Second option is the energy stored in the capacitor decreases K times. Third is change in energy stored is half CV square within bracket 1 by K minus 1, and the charge on the capacitor is not conserved. Now let's understand one by one all the things. The first option was regarding the voltage. As the charge has to remain constant because the battery has been disconnected, so voltage has to decrease since the capacitance has increased. Secondly, for the energy, we have got 3 formulas: half CV square, half QV and Q square upon 2C. But it is advantageous to use Q square upon 2C because Q remains constant. Remember, whenever the battery is connected and some changes are made in the capacitor, the voltage remains constant. Now since the battery has been disconnected, the charge is constant. Hence Q square by 2C formula we will use, and we know since the capacitance is increased, so the energy has decreased by some amount, U dash U by K. Let's talk of third value also, the change in energy. Final energy will be Q square upon 2CK. Again I am using the formula Q square upon 2C since Q is constant. So when we solve it, we get Q square upon 2C within bracket 1 by K minus 1, and since the option is in the terms of CV square, I convert Q to CV. Q will remain as CV, new CV. That's half CV square 1 by K minus 1. So this is the third option, which is also correct. Fourth, battery is removed, so charge on the battery cannot change. We must remember, ये बात हमको पहले स्टेटमेंट में ही क्लियर हो गई थी, ये तो बाकी 3 मैंने आपको सॉल्व करके बता दी. Whenever the battery is connected, the voltage is constant, and if in such question, if the battery has been removed, the charge has to remain constant because there is no agency to give or take the charge. So obviously our answer will be the fourth one. Let's go for the next question. A certain electrical field in a certain region is acting radially outward. It is given by E is equal to AR, where A is constant. A charge contained in a sphere of radius A centered at origin of the field will be given by. Now you see here the electrical field is radially outward. That means first thing is clear, the charge has to be positive within the conductor. And in such questions, electrical field is given and we require the charge. We very well know the Gauss law will be a suitable thing to use. So we use Gauss law. I have made a Gaussian surface which is shown here. Now electrical field into area will give you Q by epsilon naught. So I have taken the sphere of radius A, so E into 4 pi A square. Now E is already given as A into A, capital A into small a. So I multiply by 4 pi A square, it should be equal to Q by epsilon naught, which gives that the Q is equal to 4 pi epsilon naught A cube. Straight question hai. Hence our correct answer will be number 3. Let's go for 1 year prior. 2 thin dielectric slabs of dielectric constants K1 and K2 are inserted between the plates of capacitor as shown in the figure. The variation of electrical field E between the plates with distance D as measured from plate P is correctly shown. First let us see what is the question figure. This is the question figure. Remember, the K1 and K2 are 2 dielectrics, and the options over here 1 and 2 and 3 and 4 are given here. Remember, one thing is very clear, that I just forgot to mention that K2 is greater than K1, which is there in the question, which some by mistake I couldn't write down. K2 is greater than K1. So remember, electrical field within a dielectric constant, if outside field is E by K. जब भी आप डायलेक्ट्रिक स्लैब को रखते हैं तो इलेक्ट्रिकल फील्ड बीच में रिड्यूस होगा, और रिड्यूस होगा E by K टाइम्स पे. सिंस K2 का डायलेक्ट्रिक कांस्टेंट ज़्यादा है, K2 हैज़ गॉट मोर वैल्यू, सो इलेक्ट्रिकल फील्ड रिडक्शन विल बी मोर इन K2. So we can see in the first part, option number 1, at one point electrical field is decreased and also increased in the second part. This is decreased here and increased, which is not possible because it has to always decrease. Second option is this is decreased, this is a further decrease. I think this is our answer. So 2 is the answer. Third is talking where electrical field is totally zero between them. This is not the case, which would have been the case if the slabs would have been conducting one. और नंबर 4 तो किसी हालत में पॉसिबल नहीं है, बिकॉज इलेक्ट्रिक फील्ड कैन नॉट इंक्रीज. हेंस माई आंसर विल बी नंबर 2. Let's see again question. Here we are given the potential Vxy in the form of V6x minus 8xy minus 8y plus 6yz. V is the volts, xyz meters. We have to find the electrical field experienced by a charge. It is to be electrical force experienced by the charge. Force उसको कितना लग रहा है, 2, because field. अब हमारे पास ऑप्शन है 30, 24, 4√35, 5√5. पहली चीज़ यहाँ क्लियर होगी, मुझे फोर्स को IJ में नहीं निकालना है, बिकॉज माई ऑप्शन इज इन दी स्ट्रेट टर्म विच इज विदाउट IJ, इट्स स्केल ऑफ टाइम. सो आई हैव टू डू concept. Firstly, we have to go for concept. Voltage is given, we have to find electrical force, that means electrical field. So we know that electrical field is defined as the potential gradient, rather negative of potential gradient, minus dV by dx. अब यहाँ पर जिन्होंने मैथ्स नहीं ली वो थोड़ा सा प्रॉब्लम महसूस करेंगे. हमको बेसिकली E इज इक्वल टू वोल्टेज को डिफरेंशिएट करना है, एक बार x की टर्म, एक बार y की टर्म, एक बार z की टर्म. When you differentiate in terms of x, you will take yz as constant. When you differentiate in terms of y, you will take xz as constant. And when you differentiate in terms of z, you will take x and y as constant. मैंने वही आपके सामने डिफरेंशिएट कर दिया. सिर्फ पहले से समझ लीजिए, जब आपने dv by dx और i कैप किया है dv by dx, तो 6x का हो जाएगा 6 और 8xy का हो जाएगा 8y. बाकी दोनों क्वांटिटीज़ में 8y और 6yz में देयर इज़ नो टर्म कंटेनिंग x, तो वो डिफरेंशिएशन का उसका आंसर 0. ऐसी हमने तीनों की वैल्यू कर दी है. अब इससे इलेक्ट्रिकल फील्ड की मेरे पास वैल्यू आ गई 2i + 10j - 6k. नाउ यू हैव टू फाइंड द मॉड्यूलस ऑफ दिस, बिकॉज एज वी डिस्कस्ड हमारा आंसर IJ में नहीं है, सो वी हैव टू बी लाइक दिस. So by what we get 2² + 10² + 6², which is 140, which is 2√35. Up to 2√35 is the Newton per coulomb electrical field, but we have got the force of 2 coulomb, so we have to multiply this by 2 coulomb, and what we get is 4√35 Newton is the answer. That is my answer will be the third one. आइए एक और क्वेश्चन इस टाइप की आप देखनी हो तो यू कैन सब्सक्राइब मी ऑन माई वीडियो चैनल, और मेरे ऑनलाइन कोर्स के लिए यू कैन join me at the various contacts. There's mainly contact is adarsh@hsa@gmail.com. Thank you.